In this video, we're going to talk about the second type of models, logistic regressions. So again, we read in our data. I do a conversion of sex, which is male, female, into 0, 1 numeric. You don't have to do this, but sometimes some of the functions prefer to have it 0, 1. So that's why I do it here. Now, GLM, general linear model, predicts sex numeric 0, 1 by height. Taking our data, and our family is binomial. What we see here is height is a significant predictor of the gender. Yeah. Now, I'm going to leave it up to yourselves to have a look, but you'll need to learn a small bit about AIC later on to be more confident about how to compare logistic models. But for the moment, what you need to know is the AIC of the model is much lower than the null. The null is nothing is significant, and you want the AIC to be lower. We can look at our confidence intervals, which is the same as our p-values. We see our confidence intervals on the parameters, and we have our coefficient as well. Now, and we can have a range in our coefficients as well, and our exponential coefficient. So to plot this using ggplot, geoplot tells 2 points. I include color as iColor just once again to show, even by including something as simple as 4 categories, it makes it very messy. To add the fit, we'd say GLM spoon, and we tell it's a binomial family. And we can include standard errors as well, so error bars if we want. So we have our fit, and then the grayed area is actually error bars. So the distance, so it's very nice. We want nice and tight error bars for this. And there's our data, and there's our data. And we see there's no kind of pattern with respect to eye color. Yeah. To build upon the logistic regression, you can start adding in variables just like the linear regression, add in age, height, swimming distance, reaction time, factor of eye color. And we have our model here. Height is a variable and age is significant. The others aren't. Yeah. Once again, you can look at AIC. Sadly, it's not as good as R squared because R squared really has a tangible comparison, but all you need to is AIC versus null is what you want to be looking at. Okay. But another way, like with the linear plot, is what about the residuals? So you can plot the fit. Now, that's not a plot of the result, it's a plot of the residuals, just like in the linear example. But because it's not linear, because it's logistic, you'll have a separation of curves. So that's for noughts, and that's for ones, or vice versa. It doesn't really matter. And what you want to see is that the dots sit along the curve, and they do. Once again, there are 3 outliers sitting there, which you can dig into by looking at what's different about those. But they're not very big. They're not that far away from the main group. I wouldn't spend a lot of time getting rid of them. Similarly here, our QQ plot, which is standard deviation of residuals against quartiles. Now here it does deviate in the tail end here, but not hugely. Once again, I wouldn't worry a lot about it, but it's good to have a look at it. Square root of standard deviation of residuals should have this X shape, and it does. Once again, we see those 3 points which were causing issue. So maybe keep in mind about them. As I said before, because the n is so large, I wouldn't worry too much. And lastly, our residuals versus our leverage. It's a Cook distance, which you can read about. We have our 3, 4 data points that are considered outliers, but they do fit along the graph. So everything's pretty good within reason. Once again, we can look at our 95% confidence intervals on the intercepts. What we see here is that doesn't cross 0, so significant. That doesn't cross 0, significant. All these others cross 0, so they are not significant. And we can look at the exponential coefficients to once again see what the odds in favor or odds against would be given the values of the estimates. Now, we might want to add or subtract variables to our model. Just like in the linear model, we just use the command update. Dot, tilde, plus weight. Yeah. And now that adds weight into our model, just like in the linear. So while we use a GLM for the logistic, the update is the same as the linear model. Once again, It doesn't really impact AIC. And then we can take away something. So take away swimming, and it slightly reduces AIC. Now, our AIC is a function of both the reliability of the model and the number of variables. So AIC actually is kind of better than R squared to think about the model, because it takes into account by adding in extra variables, it should charge you, it should cost more. So the AIC, that's why it becomes complicated. And you can read about that in your own time.